Okay, so just a quick attendance. Marvik over here? Okay, thanks. Sarah? Okay, in back. Got it. Ellen is here, right? Tiffany is here. Ashley Hernandez? No? Okay. Earl Holloman? Earl? No. Pono? That's right. Okay, right. That's right. Sophia? Sophia? Okay, thanks. And then Noah? Noah? No. Joshua McDaniel? No. Des? Not here. No. Okay. Christopher Lindsay? Okay. Benjamin? Okay, thanks. David is here, right? Eric Wallace? Eric Wallace? No. Okay. And then Ethan Wenzel? Okay, great, thanks. Okay. So, let's see. Over on Laulima, under syllabus, there's a handout. And also on that page, there's another handout on keyboard shortcuts. So, over on Laulima, under syllabus for today, there's the usual PDF, but then also underneath, there's this intro to keyboard shortcuts for Excel. So you may want to have that one available too. Okay, and it's also under resources on Laulima. Okay, so yeah, so you may want to get this intro to keyboard shortcuts for Excel. It's on Laulima under resources and should also be linked to the assignment for today. Okay, and so any questions before we get started? No? Okay. Let's see. So we'll also be using Excel today. So you can launch Excel as well. Okay, so we want to sort of do just a few more time value of money problems. We already mentioned that there's two types of annuities. We'll really be focusing on the ordinary annuity, but it's good to leave space in your mind for, oh, whoops, sorry. Okay, yeah, so again, doing some TVM problems today. There are two types of annuities, right? Ordinary annuity and annuity due. We will be focusing on the ordinary annuity in this class, but you need to leave space in your mind for the annuity due. And what we want to do now is do sort of a full amortization table for a mortgage, for an annuity, mortgage annuity. Okay? And that'll be related to the Excel assignment. Okay. So, just as a review, suppose, Anne deposits $100 in a 1-year CD that pays 6% interest. How much will she have at the end, right? So you really don't need any framework to do something this simple, right? Because you basically want, the fair value, the future value at time 1 or 1 year from now, and they're depositing $100. So you have your principal. And then what you're going to do is you're going to earn 6% additional at the end of the year, by the end of the year, right? And so at the end of the year, you'll have $106, right? That's really simple. But, another way to do that, right, is to convert the interest rate to a decimal, right? And then now you can see, I have $100 here and $100 here, this same principal or present value amount. And so since I have 100 here, I have 100 there, I can factor that out. And so now it's really 1 plus 0.06, the decimal percent. And then I have this factor, really, 1.06 times 100, and then that gives me the 106. So if you wanted to do this sort of the long way using the framework, right, you start with the compounding periods, and we always start with the annual compounding period, and then you look at the number of periods, and in this case, it's just 1 year, right? Interest rate, 6%, and we know the present value. We might say that she's depositing $100, so we could put in negative, and then now we know that the PMT is an annuity amount, and there's no annuity here, right? And the future value is what we're looking for, so we might put the question mark over there to help us remember that that's what we're looking for. Okay, so if you wanted to do this in Excel, you would do the future value function, and then you would say refer to the interest rate cell, maybe, which would be 6%, and then you would refer to the N cell, which would give you just 1, and then it asks you for the annuity amount, right? So you might refer to that cell, which would be 0, and then you have to specify the present value, which would be the negative 100. Right, so if we do that in Excel, sort of very quickly, it's good practice to just jot down that little compounding. Why is it doing this? Sorry. Well, if you get a new worksheet, that's actually good advice, right? Pivot tables are not as hard as you think, but anyway. So what we want to do is we want to do the TVM data frame. So it starts with compounding, and then, the number of periods, the interest rate, and then the 3 cash flows, PMT, and then FV, right? Okay. It was working, right?
No.
It wasn't? Oh, sorry. Okay. Somehow I thought it was. Okay. So.
Can you go over it again?
Oh yeah. So, what we were looking at was this simple problem where a person deposits $100 for 1 year, and it pays 6% interest, right? So the question is, how much will she have at the end? And you can do this without any framework, but since we know the answer, let's practice using the framework, right? And so you would start with the 3 sort of environment variables, the compounding. Here it's annual compounding, so we'll put 1 there for annual compounding. The number of time periods it's 1 year, so it's only 1. And then interest rate and the present value, you could say she's depositing $100, and we know there's no annuity amount, and so here's the future value. How much will she have at the end? So the end is the future value amount. And so this is really what we would be using in Excel. And so what we should do in Excel is, we start with a blank sheet, and then we should just type in C, N, I, PV, PMT, and FV. Okay? And then if you want, if you select the first column, you can press and hold the shift key, and then if you tap the right arrow, you can keep selecting these columns, and then you could say center them. And then maybe you could click, say, on the first row and select bold and make them a little bit bolder, right? Bold. If you wanted to use the keyboard shortcuts, one of them is to select. If you look under the selecting regions, if you do Control Spacebar, it selects a column, and Shift Spacebar selects a row. So to select a column, like I guess Control would be like column. You could say, so if you press and hold Control and tap the spacebar, then you would select a column, and you hit Escape, or maybe the left arrow. And then when you want to select a row, that would be Shift and then the spacebar. Right. So again, if you hit the left arrow, that sort of cancels it. So once again, Control, column, spacebar, Control for column, and then you can press and hold the arrow key, and then select columns with Control spacebar, and then Shift the spacebar would allow you to select rows. And so again, if you press and hold the Shift key and the down arrow, that's how you can select a region. So again, on the Intro to Keyboard Shortcuts, that will be under the selecting regions, Control spacebar to select the column, and Shift spacebar to select the row. Okay, and so we always start with annual compounding, and here it's just 1 year, 6% interest. Well, the present value is minus 100. The annuity amount is 0, and then the future value is what we're trying to calculate, right? So I'm going to just try to make this a little bit narrower. So H-O-W, Alt-H-O-W, and so let me just make that 1. And then if I go back home, it should fit now. Okay, and then somewhere maybe below FV, either on the 3rd row or maybe the 4th row, you can put, say, equal FV future value, and then it prompts you for the interest rate, so you can select the interest rate, and then after you type in comma, if I hit a space bar, I think it makes it a little bit easier. It tells you, okay, so the next one is the number of periods, so that would be the 1 there, and then I hit comma, and then I'm back here in this area. PMT would be 0, comma, space, and the present value would be minus 100, and then when I type the close parentheses, the right parentheses, and hit enter, that gives me the 106. Okay. Notice, right, that this is the depositor's perspective. So the present value is negative, so the cash flow is leaving, and the present value, and then the future value is positive. So in the end, you receive that. If we get rid of this minus sign and change it to positive 100, this is now the opposite side of the transaction. Here, the present value is to receive, that would be the bank. So when you deposit, that's negative, and so the opposite side would be plus to receive. And then a year later, since they received your deposit, they're on the hook to pay you, return your principal and pay you the interest for using your $100 for that period, that 1 year. Okay, so if you kind of, understand that, right? If you want this value, the resulting value, to be positive, one option you have, of course, is to make the value negative, right there. And then it looks negative, but which would be fine. The other option would be to put a minus sign, say, in the formula, and then, you know, everything seems to be positive. And so maybe that's what you'd like. If you'd like to just see everything positive, then you can make this positive, and then, you know, understanding that if you leave off that minus sign, that sort of gives you the true cash flow picture where you're receiving 100, and if you receive a present value, then you're on the hook to pay it in the future. But if you're kind of just doing work with the numbers, you may want to just throw in a minus sign into the formula, and then all of your values are positive. Okay? So that's kind of, as they say, beating a dead horse, right? Oh, and then, of course, if you wanted to use the calculator, these are the time value of money variables, and this payments per year is sort of like this compounding variable. And so again, as I mentioned, it's while you're a student, it's better to have these set at the value of 1. And later on, when you always deal with monthly mortgages, if you become a real estate professional or you're in finance and you always deal with semi-annual bonds or you always deal with quarterly bonds, then your life can be easier if you put, say, 12 in there for dealing with monthly mortgages, or 4 for quarterly, 2 for semi-annual. But if you're a student and the compounding is going to keep switching on you, I think it's better to just set it to 1 and sort of forget it. Besides, if you're going to use Excel, Excel assumes that the compounding is 1, and so you handle the compounding basically in the second row, but we'll get to that later. Okay. Oh yeah. So how do you do that, right? So for so C, we've already set no is 1 from before. Here we push 1 and then n, so that sets the value of 1 into the number of periods. Here we put in the interest rate and we put it in the percentage. So we do not make it the 0.06 decimal. You put it in as the percentage here. And then if we put in 100 to the present value, we can compute the future value. Let's see what happened. Recall of PMT must be. Oh yeah, sorry. I didn't do clear TVM, and so what happened? Well, so what happened? I had this value of almost $600 in my PMT, and so it assumed that there was a present value and a PMT, and so that's why the future value was off. So really, I should do clear TVM. Do it again, and then so again. Now that the TVM registers are clear, put the 1 in there, put the 6% in there, put the 100 for the present value, and now when we compute the future value, we should get this negative 106. And so again, that's because we put in a positive 100, meaning that we're going to receive 100, and so we have to pay it back in the future. So if we put in negative for present value, that means that we deposited it, then in 1 year we have a plus. So negative was in the beginning, right? So that's where we're depositing it. The cash is leaving us, and then in the future, the cash flow is coming to us because we receive it back, right? So that's how you do it in the calculator, okay? Next problem really is just now B is doing a 2-year CD at 6% interest. How much will she have? Again, so now the new start is, so for the first year, you repeat this calculation and then it doesn't do anything. And so for the second year, you have another instance of it. So you run it beginning with 106 now. So for the second period, your starting point is now 106. So you receive the 6% on $106, and so you have not 112, but 112 and 36 cents. So the 36 cents, of course, is interest on the interest, because you earn a little bit extra. 6% interest on $6 will be the 36 cents. Okay? And then similarly, right, factor it out, and now there are these two factors of 1.06. So you can take your original amount times 1.06 squared, and then you get the same answer, right? So if this were our problem, we would basically have, write in 2 for the number of compounding periods, and all of this other stuff would be the same. And then the FV is the question mark. So actually, what we can do is we can just reuse this and type in 2. And so it updates now, because our formula used the 2 is referring to n. And so since we referred to the cell, once we change it in the cell, the data cell, then the formula is updated, right? And similarly, in the calculator, we do not have to do the whole thing over again. We could just simply update this to 2, so the 6% still is there. The initial PV is still the same. There's no annuity amount, and now when we calculate the FV, we get the same result. Okay? And then, similarly, CARA, right? 3-year CD. Everything else is the same. So now the starting point is the end of the second year, right? Because for the first year, you would do this for CARA. For the second year for CARA, you would do this, same as B, right? Except now CARA is now 3 years, and so the starting point is the end of the second year. So you run that forward, and really, if you do the same factoring out, you now observe the same thing, right? So now there's 3 annual periods, 6% interest, same present value, no annuity, and we would like to compute the future value. So again, same thing. We can just type in the 3 there, and we update the future value amount. And then similarly, in the calculator, we have the same basic information, except that now we're looking at the 3 years. And so we compute the future value, and so we get the same answer, up to rounding, of course. Okay, got it? So the question is now, suppose Nancy, now N, deposits some amount, present value amount, in an N-year CD that pays I% interest. How much would she have at the end? Sorry. How much would she have at the end? Right, so now we're looking at FVN, right? And so we're looking at something like this, right? So FV after N periods would be something like this, right? So you have 1 plus the interest rate, right? And how many periods is it raised to? The exponent should be what? Right, when it was 1 year, the exponent was basically 1, right? When it was 2 years, this exponent ended up being 2, right? When it was 3 years, the exponent ended up being 3 times the present value, right? So when it's n years, you're going to have that factor n times, and then you multiply it by the present value. Okay, so we're just basically taking this formula or this relationship, and we're extending it from 1. Here it's 1. The power is 1. 1 year, the power is 1. Here it's 2 years, right? So it's squared. 3 years, it's cubed. So n years, it's n. Okay, so this is the basic formula, right? So discount factor is going the other way. So Al now, say, needs $100 in 1 year. If he can earn 6% interest, right, how much should he deposit now to have $100 in 1 year? Okay, so basically we take this equation as the starting point, and right, it's just math, right? So it's just math, right? So we can divide by do a little algebra, right? And so now we have this 1 plus I to the n times a future value however many periods out. So we basically have this relationship. Okay, so how would we fill in the TVM table, right? This is how we always started out. So n would be just 1 year. Our interest rate is the same, 6%. Now the question is, what is the present value? How much should he deposit now to have 100 in a year, right? Al needs $100 in 1 year. So $100 in 1 year, what's that? That's the future value, right? So he needs to have 100. If he has this way to earn 6% interest, how much should he deposit now to have 100 in 1 year? And so the present value is what we're trying to calculate, and then there's no annuity, right? And so we're going to be using the PV function in Excel. So it asks for the interest rate first, right, which would be 6%. Then it asks for the number of periods here, which is going to refer to the 1. And then it asks for the PMT, which we're going to refer to the 0. And then we need the optional future value, which we're going to refer to over there. And then we can close it out, right? So to save some typing, right, let me just clear that formula. And now we'll put 100 over there, and then now the present value is what what we want to calculate. And okay, so I'm just gonna make these cells a little bit narrower, and so on the keyboard shortcuts under formatting. You can open up, say, here, Alt H O I, and I think on Mac there is no analog for this, right? So basically, the Alt H is going to open the ribbon, and then when you type O, we're going to go to the formatting window of the ribbon. And then on the formatting window, there's the I, which is basically auto-fit the column width. Right? So again, I want to make these a little bit narrower, so I have to select them. So Alt-H basically brings down the ribbon. If you look, I want to pull down something from the Format menu, and so that's actually O. So I can type O. And then you can see that there's several different choices that I have. And the one that I want is this one, which is auto-fit column width, and it's actually I. So let me try that again. Alt-H, and then O, and then you can see that the auto-fit column width is this letter I over there. So if I type I, oh no, that's not what I want. Alt-H-O-W is what I want. I want to set the width to be, say, 5. Okay, so that is Alt-H-O-W. I guess I don't have that one on the short. I was trying to fit everything on one page, right? So again, Alt-H-O-I is the autofit, but Alt-H-O-W, Alt-H-O, and then W is where you set the column width. So if you push W, that's where it asks you how wide do you want it to be. Oh, maybe I'll make it 6. It's a little bit wider. Okay. So now we're back to where we want to be, and so to calculate the present value, you do PV. Then it's best to refer to the rate, comma, and then the number of periods, comma. Oops, I did a period by mistake, comma. And now we're looking for the annuity amount, so let's get that from the TVM data table, comma space, and then the future value we'll say put in as here it's positive, and again, sort of thinking ahead, we would like the result to be positive. So now this is where it's good to do the Alt-H-O-I and then let Excel figure out the right width so that you don't get the I don't have enough space, like all of those number symbols. Okay. Similarly, right, B needs $100 in 2 years, right? If she can earn 6% interest, how much should she have now to save, have $100 in 2 years? So basically we can just rely on the formula, where n is 2 this time, and so we get 89. So again, if we were doing this, say, from scratch, we would say it's 2, it's 6%. What is the present value? There's no annuity, and here they're really, say, wanting $100. So the sign actually doesn't really matter, and so we just put in 2, and we get 89. Oh, you know what? I think I forgot to do it on the calculator, so we'll do it really quickly. And so here we'll just put in $100 for the future value, and then let's see what we have in n. In n we had 3 from 4, so actually let's set that equal to 1. Okay, and now we want to compute the present value, and that is our $94.34 basically. Oh, oops, $94.34, right? And now we'll do the second case where n is equal to 2, right? So we can just do 2 and put that in n, and then when we do compute the present value, we get the $89, right, and 99.96 cents, and so we round that up to 89.00, 89.00. Okay, and then the next one is 3 years for Kara, so we'll just do 3 and put that in n, and then we can compute the present value, and so that's $83.96. So you can see, yeah, it's really just the formalism is, or the formula is just doing this calculation, but we don't have to worry about exponents and dividing and all of that stuff, right? So if you're doing this from scratch, right, this would be 3 years. The interest rate would be 6%. Present value is what you want to calculate. There's no annuity, and here the present value, what they want in the future is $100. And so if you deposit $100, if you deposit $83.96 and you leave it there untouched for 3 years, if you're earning 6% compounded annually, then you'll have your $100, right? And so you can, to sort of check, right? We know that the future value, right, is equal to 1.06 to the third power times the present value, right? And so what is the present value? So here is 1.06 cubed, right? So the present value is basically this, right? So instead of writing the present value as $83.96, the $83.96 is really 100 divided by 1.03. Is divided by 1.06. The 3 is up there, right? And so if you cancel out the factors, you get 100, right? So in a way, if instead of seeing this as numerically $83.96, if you see this $83.96 as this 100 divided by 1.06 cubed, then it's easy to see the cancellation, right? Otherwise, long way, you would just say equal $83.96, and so you would say multiply by, and let's put this in parentheses, 1.06 y to the x 3 close parentheses equal, and so we basically, that I just took the 83.96 and I multiplied it by 1. So the calculation I just did was 1.06 cubed times this $83.96, and then the numerical calculations show that it's 100, right? So if you need FV certain years from now, how much should you deposit now? So that's basically the present value is this 1 plus I to the nth power times some future value n. So that's actually what we knew from before. And so this one, starting with the present value and moving it forward, this one's sort of easier to think about. Instead, you deposit now and then you move forward in time. And going backwards, like, I have this amount in the future, how do I get it back? They're really, the same. And so if you remember this one, you can actually remember the other one. But of course, if you have the calculator, it'll handle all of that for you. Does that make sense? Just a bit of a review. And so now, when we do compounding periods of less than 1 year, right, because a lot of business problems involve compounding semi-annually, compounding quarterly, compounding monthly. How does that change the factors, right? And as we mentioned before, when do you receive the 6%? You receive the 6% at the end of 12 months, at the end of the year. If you're doing semi-annual compounding, then you award interest after 6 months, after half of the year, right? So after half of the year has transpired, after half of the year has gone by, you only earn half of the interest, right? But in the second half of the year, now you can actually earn interest on interest. So the semi-annual compounding has a little bit more. The quarterly compounding, the amount that you earn is just 1/4 of the original amount, and you earn interest on interest on interest, here and there, and then monthly, it's sort of the most. So, this gives rise to, okay, depending on the amount of compounding, semi-annual, quarterly, or monthly, if I leave the funds untouched for 1 year, what do I get? Instead of telling me it's 6% compounded monthly, how much interest will I have at the end and of 1 year? And that makes it a little bit easier to compare. What's the difference between, so if your question were, say, 6.1% annual versus 6% semi, which one should I choose? Right? Say, well, wow, if I 6.1% annual interest versus 6% semi-annual, you'd have to sort of work it out. And so that's why there's the idea about the effective interest. And so that makes it easier to compare whether it's compounded semi-annually, whether it's compounded quarterly, or compounded monthly, right? So by converting the whatever, 6% compounded quarterly, 5.8% compounded monthly, in order to net it all out and make it easier to compare, if we just convert all of the interest rates to, on an annual basis, what are they? And then that makes it easier to compare, right? So basically, how do you find the effective rate? So you from what we did before, hopefully you can see that every year we get this factor, right? So if we compound for 1 year, it's just 1.06, right? After 2 years, it's this 1.06 squared, right? And then after a third year, it's 1.06 cubed, right? So what do we want in order to find the effective interest rate? What do we want? We want the equivalent rate where we can just do 1 plus r for the year. Right? If we find this 1 plus r, one single factor for the year, that's what we want. We want the effective annual interest rate. But what's happening, right? So every time you do compounding, what's really happening to this, and we'll call this the nominal rate, the 6%. It's the rate in name, or the rate gets its name from this, 6%. We're really taking the compounding, and halving the interest rate. But if we half the interest rate, then we actually square the periodic factor, shall we say? Okay. So if the compounding rate is 2, right? If we take this formula, so obviously we're looking for the rate, which is this, minus 1, right? Not a big deal, right? So r is equal to this factor minus 1, so we get the rate. We take this 6%, right, decimal 0.06, and we're really halving it. But then this 1.03 is really the amount for half a year, and so we need 2 of those to do it for the whole year. We get this 1.609, and then if we subtract 1 from it, we get the rate, which is in decimal, and then in percent, it's 6.09%. You see? So that's how we get this rate. So now you can compare the, say, 6% semi-annual. So what is 6% semi-annually? 6% semi-annually is 6.09. Whereas the 6.1, it's a full, it's like 0.01 larger. If it's $100 or $1,000, it's not a big difference. But on $1 million or $10 million, this extra 0.1 is going to be a bigger number. And so you might go with the 6.1 annual interest rate and say, I'm going to pass on the 6.1 semi-annual because I know that really it's going to net out to 6.09%, which is a tiny bit less than the 6.1. Okay, does that make sense? So this effective rate helps you net out. On the other hand, if this had been 6% quarterly, right, with quarterly compounding, you would be 6.14, right? Then you would say, oh, I'm going to pass on the 6.1 annual, and let me do the 6% quarterly compounding, or 6% monthly compounding. Okay, and so again, on the calculator, there's this iConv, which is the interest conversion worksheet. Just go to iConv, right? And then here, say for a nominal rate of 6%, what is the effective rate? And so we go down and we say we want compounding to be 2. So you do 2 and enter. Then when I return to the effective rate and compute it, I get the 6.09, right? And then again, if we go down to quarterly compounding, right, and go back up, and then compute the effective rate, it's 6.14%, right? On the other hand, some people might say, if there's 6.1 effective rate, we have quarterly there. So what is the nominal rate? So you can actually compute that. Let me say, 6.1 and then enter. So we do 6.1 enter, and then I actually compute that. So 5.97, say 5.97%, if that's compounded quarterly, that's equivalent to an effective annual 6.1. So it is possible to be given the effective rate and then to recover the nominal rate that would be, in this case, compounded quarterly to give the 6.1 effective. Okay, so So it's in the first case, it would be, we're given this nominal rate and the compounding, so compute the effective rate. On the other hand, if you know the effective rate and the compounding, you can go back and calculate this nominal interest rate. And so instead of doing all this algebra, the calculator computes it for you. Okay, oh, and so here, quarterly compounding would be done this way, basically. Okay. Let's see. Oh, okay. So now we'll look at the effect of compounding, right? So suppose Camille deposits $100 in a 3-year CD that pays 6% compounded semi-annually. How much will she have at the end, right? So now we see that she deposits $100. So the present value would be $100. 3 years, so we're talking about 3 years, right? And it pays 6%. 6%. And now we have to do the compounding semi-annually. So we have the second row. Okay. And so remember, when we do the semi-annual compounding, the interest rate is not this full 6%, but it's half. So we basically take the interest rate and half it. Okay. And then the number of compounding periods. Remember, when it was 1 annual period, we went to 2. And so here, if it's 3, if it's compounded twice a year, instead of being 3, it's going to be 6, right? So this is really n times c, and this is really I divided by c, right? And then here, there's no annuity amount, and the FV is what we're calculating. And so the FV, again, would be the interest rate in Microsoft N, no, and then the PV in this case. Okay, and so if we wanted to do that in Excel, now we're down to the second row, and we have semi-annual compounding. So we can actually do equal n times c, right? And then here we would do the equal, say, the interest rate divided by. You can hit home and then jump there and hit tab. Oh, and then if you wanted to change this to percent by using the mouse, there's this number format window. And so if you click on that, this gives you the format cells. A quick way to do it would be to, say, pull this down and switch to percentage, right? And then if that looks like it's too many decimal places, you can sort of manually just correct it. If you wanted to open the number format with the keyboard shortcuts, it would be open for formatting, so you'd be changing the number format. It would be Alt-H Fm, and so this opens the format window. And then you would use Tab and Shift Tab and arrow keys to cycle through them. So Alt-H Fm opens this formatting window, and if you look very carefully, you can see there's this outline over there. And so as I hit the right arrow key, I can go through the different tabs, right? So now that I'm, say, on this tab, the question is, how do I go down and access the parts of the tab, right? Because if I keep hitting the arrow keys, I switch to tabs, the tab up there. And so to move into these, I hit the tab key on the calculator, and now I'm actually in this tab. And so what we would want to do is, say, move it to percentage. By default, you come over here, and you can actually type the letter. So if I want percentage, I can type P, right? If I wanted, say, scientific, I type S, and then it sort of scrolls through. Notice that for, say, percentage, there's only one P. So if I keep hitting P, I stay there, right? If I want currency, I type C. Oh, there's actually two, sorry, with C. Currency and custom, so I keep typing C. I toggle between those two. Again, S. would be those, but here I want P. So I stayed there at P, and then maybe for the sake of argument, I want 1 over there, and then when I hit enter, I can do it totally on the keyboard. Okay. Let's see. And so here actually we are looking at those values. And so if you have the formula there, what you can actually do is you can actually drag this down. And so now instead of typing, I can actually modify the formula. Oh, but wait, we wanted to do. Sorry, this problem is a future value problem. Yeah, oops. So maybe yeah, that doesn't matter. Okay, but anyway. So we would want to. Oops, sorry. So we want $100 deposit, and then here in this case we want to calculate the future value. So again, that's equal to FV. And then we do the rate. And then again, so we're using the second row now because of compounding, comma, the number of periods is 2 annual periods, but 4 semi-annual periods, comma, space, PMT, let's refer to this cell here, which is 0, comma, space, and then the present value is this. And so I know that it's going to flip the sign. So if I leave it that way because this value is positive, then the value that comes back at me would be negative. If I want to see positives all the time, then I can leave this positive, and understanding that it's going to come back to me as the opposite sign. Let me make this one negative, and then that way, sorry, so to fix that, we do again Alt-H, O-I, which is the autofit, and then Excel will just take care of formatting that for us. Yeah, does that make sense? Okay. So here's just a few more compounded quarterly, right? We basically put the 4 over there, and then the 6%. Oh, sorry, the 3 years, right, becomes 12 quarterly periods. And the 6% divided by 4. So you first divided by 2 becomes 3, and divide by 2 again is 1.5%. And then everything else is the same, right? So in Excel, we could change this to quarterly compounding. And so actually, since we built the formula correctly, since all we had to do is update. Wait. Is it 3 years? Oh, sorry, it's 3 years. Oh, yeah, I didn't update. So sorry, let me put that to 3. And so now we're getting the 12, getting the 1.5%, and we're getting this 119.56. So on the calculator, kind of to check that, let me do second clear TVM. Oh, actually, let me do second quit, return back to the normal mode again, and then do second clear TVM. And so here we want 12 quarterly compounding periods. We want the 1.5%. So we put that in the decimal format. Our present value is 100. And then because I want to see plus, I'll just put that in as positive, and then we want to compute the future value, and so we're getting the 119.56. So if you have 2 ways, sometimes it helps to check that, right? And then for compounding monthly, right? Basically, we have 12 out here, and so now the 3 annual periods becomes 36, right? 6% divided by 12 is 0.5%, and then the others are the same. In Excel, all we have to do is update the 12, and so this converts now to 36. The 3 annual periods becomes 36 monthly periods. The interest rate over 6% annually is 0.5%, 0.5% per month, and then the future value is computed for us. Here we have to put in the 36 monthly periods, and then we have to put in the 1.5%, and then when we compute the future value, wait, I must have done something, right? Oh no. Sorry. Let me try that again. So we'll do 36, right? And then we did 1.5%. Oops. 1.5%. Present value of 100, negative, say. And then when we compute the future value, oh no, sorry, it's not 1.5%. It's 0.5%. Sorry, there we go. And then, oh, whoops, quit. We'll do, say, compute the future value there. Oh yeah, sorry. I was doing the quarterly, and so I was doing quarterly must have been 9 years, right? If we take this 36 and divide it by 4, we get 9 years. So I was doing 1.5% quarterly for 9 years, and then that's why I was getting the big number. Okay, so again, sorry about that. Recall, so now we have 36, which is monthly. Yeah, monthly. Which? What we're doing is we're sticking to years. So all this set of problems was 3 years. So the C, A, B, C. A was the 1 year, B would be the second year, and C would be the third year. But we're varying the compounding, quarterly and then monthly. So C, third letter of the alphabet, 3 years. Okay, so if you do this, and what's going on, right? So how much do you have at the end? The future value after, say n years. What we're not really dealing with years because of the compounding, right? We're not really dealing with years. We have to deal with the compounding periods. So we're really dealing with this, right? And this is n times C, right? And this interest rate is really I divided by, right? So we shouldn't put 3 years. We should put 36 periods. So that the future value after 36 compounding periods, right, is equal to 1 plus I over C to the C times the present value. Okay, so with the compounding, right, this nominal rate, which is for the whole year, right, you have to divide it by the compounding periods. And then if n is the number of years, then the true number of compounding periods is the number of years times how often do you compound per year, right? So this is actually the formula that we're dealing with. And to help you get these values correctly, I think it's helpful to have this table, where you, gather the data, because the data is annual, and then you have the compounding, and then this helps you to get it right. And so if you're checking yourself and you just put numbers in here, you may not say, now what was I thinking when I wrote that number down? So, oh, I don't remember, right? If you do it in a structured way, this helps you to see that the factors is the number of compounding periods, and so that's multiplied, and the interest rate in the period is the nominal annual rate divided by the compounding period. And so this can help you to make sure you get it right, I think. Okay, so really this is sort of this data frame in more verbose form, right? So you always start with this base format, right? So if this is our one compounding period per year, this is the number of years, number of compounding periods, number of annual periods, and this is this nominal rate over the year. So PV at the beginning, and so technically speaking, the annuity amount would be on an annual basis, right? Because then you just divide it by 12. So whatever the annual is, you divide it by 12 to get the compounding period payment within the compounding period, monthly for a mortgage, right? So here's the number of compounding periods within a year, and so the number that goes here is the product of this, and then the number that goes here, the periodic rate, the rate within a compounding period is this nominal rate, I guess, divided by C. Okay, and so this would just be computing the present value. So before, on the previous page, given present value, let's compute some future values. So here, let's compute, suppose you have these monthly periods or payments in a compounding period. If you notice, it's actually, this would be annually. So the first one actually looks something like where this is 1 and 2, and so you have 1200. So this would be C equal to 1, and then it's for 2 years, N equal to 2 years. So here, this one, C equal to 2, right? This is the semi-annual compounding. So now we have the end of the years would be at the end of the even, right? So this is after 6 months now, and this is 3/4 of the way through. So now if we say what has a higher present value? So if this, the sum of the actual raw cash flows would be 2,400. Here, 4 times 6 would be 2,400. So the dollar amount is the same, and what we're really basically varying is the compounding frequency. If you punch that out, right, it turns out that the present value is more. Okay, so this C equal 4 row, C equal 4. So let me see if I can, C equal 4, right? So this would be like this, and then now there are 8 compounding periods, right? So the year is broken into 1, 2, 3, right? So this would be 1, 2, 3, 4, and then 5, 6, 7, 8. So 5, 6, 7, 8, and then instead of 600, you say it would be every 300. So 300 times 8 would be 24. 300. So it's the same annuity amount, right? And so if you do the present value calculation on that, you can see it increases. And so what you can see is that receiving the funds sooner increases the PV, right? So receiving cash sooner increases the PV. Also, it's related to compounding, right? So what is a mortgage, right? It's a plan to off large debt. An annuity really is a plan to pay off any debt, although if it's really large, then you need this special plan, right? And so pay off mort. This root word mort is really sort of kill off. To kill off any debt, but we really need the help to pay off larger debts, like when we want to buy property, right? So here's this case that we've been looking at, right? And so what we want to do is we want to look at the amortization table for this mortgage, right? So let's go into Excel, right? And for a future value, here we want to say it's 100,000. And now let's compute the present value, right? So let me get rid of that one, and we'll say equal PMT. Okay, and so we'll say just pick up this. We'll pick up the rate first. Rate, comma. Oops, I did a period again. Comma, space. The number of periods, comma, space, and then the present value. And here again, it's positive, and so I'd like my PMT to come out positive, and basically that's all we need to do. And let me change this now to 30 years. Okay, and so now I'm going to do the Alt-H-O-I trick to get it to that amount. Okay, and so what is this annuity? What is this mortgage, right? Mortgage is really for 100,000 at 6% interest. What is the monthly payment, right? So we've done this many times. It's easier to just reuse this, right? And so when we want to look at the amortization table, and here it's centered. So let me left justify, and then it'll show more clearly. So there are 360 payments. So we'll just look at the first one. We need to look at the payment number. So I'll just put in num to stand for number. So we're going to look at the first payment number and so forth, right? And clearly it's about borrowing, right? So there's some principal. And then on that principal, you owe interest. Okay, and so let me not worry about that right now. And then we know, I'll just type in excess principal, excess PMT. Okay, and so now what I'm going to do is I'm going to select these columns or just those cells, and I'm going to auto fit them, right? Because they're kind of being squeezed out. So let me do this Alt-H-O-I, and that will auto fit them. Okay, so what is our principal, right? If we have all of the values typed in to the TVM data frame, so it really is not a good idea to type in the value into the cell, right? So it's much better to refer to it. And so if you borrow $100,000 for 1 month, how much interest do you owe? Well, you take the amount that you borrowed, which is one cell to the left, right? And then you multiply it by your interest rate. And here, the interest rate in each compounding period, is 0.5%. Okay, so I'm going to hit tab. So on $100,000, right, 1% of 100,000 is 1,000, right? 1% of 100 is 1,000. And so 0.5%, or 0.5% would be half of 1,000, so it's 500. So you only owe $500 in interest, but yet you pay this PMT amount that we calculated using the PMT function. What's the annuity payment, right? So what's the extra amount? that you paid, right? So clearly, the extra amount that you paid is, well, this is the amount that you paid, this PMT, the computed amount through PMT. And so if we, from that larger number, we subtract the interest, right, we can see that the excess amount is $99.55. Right? So you make your payment to the bank or your mortgage servicing company, and the first thing they do is they say, well, you have $100,000 that you borrowed. We are entitled to 0.5% interest for that month, and so this is the amount that we're going to take. So they pocket that because that's the agreement that you owe them interest on that, and they say, you didn't just give us 500, right? You actually gave us a little bit more, huh? So what do we do with this extra amount? Well, you gave it back to us, so you haven't borrowed the full 100,000 anymore, right? So for this second period, right, you actually started owing us this amount, but now we're going to minus this excess amount, okay? And then I'm going to hit tab, and so, okay, there. So now the amount of principal that I actually borrowed is less, right? Why? Because I paid back a tiny, tiny, tiny bit. Okay, so how much interest do you owe? So what you really want to do is you want to copy the formula down, right? So I'm going to press and hold Shift and do the down arrow once. And then I'm going to do Control D, which is to fill the formula down, right? And you can see that the formula that I started with is here, right? And so it has the amount on the left times the principal, right? And so when I copied the formula down, it correctly got the amount to the left. However, it also dropped down one cell for the interest amount. So that's not what I want, right? I want, when I propagate this cell down, because what I'm really going to do, right, is I really want to do all 360 payments, right? I want to do all 360 payments. So I really want to lock on that cell, right? So I can say click there, right? And then I can just on Windows type F4. And then when I type F4, when I type F4, it will lock those for me. Okay, so now when I commit that, right, now I have it locked, and now when I say start in that cell, press and hold Shift and tap the down arrow, now when I type Control D and I copy the formula down, now it's behaving the way that I really want it to, because I want this reference to remain fixed. Because again, for the third payment, the fourth payment, and so forth, I want this interest rate here, periodic, within the monthly compounding period, want that to be fixed, but I still want to keep referring to the one on the left. And so again, similarly, right, if I just blindly copy that down, I see that it really doesn't look right. What's going on, same problem, right? So do not just go and fix that and say, now it looks right, right? Because when you copy this one down, you're going to have to, like every single one, you're going to have to fix, right? And so you don't want to, if it's just a couple rows, yeah, it's easy to just manually fix it, right? But when you copy all of them down, it's going to cause a problem, right? So what do you have to do? Same thing, except it's the blue one, right? This is the first one. So here's where you want to tap the F4, and then when you go in this cell and press and hold Shift and then do the propagate down, then this time it correctly locks onto this PMT, right, monthly payment, and it subtracts the amount on the left. Okay, so now what we want to do is we want to do all 360, right? So what we can do is we can do Alt H F I S, which is the pulls up the fill a series window. You know, I'm going to hit escape here. There is a thing, such a thing as the fill handle, and so you can, you know, manually pull this down, and you know that's fine. However, if you do Alt FIS, if you want to do 360, it really helps to do it with the fill window. So we want to do columns, okay? So now, and I'm going to press and hold Control, and then tap the down arrow. Okay, now I jump to the bottom. So I'm going to tap the right arrow and go to this cell. And what I want to do is I want to fill all of these down. So I'm going to press and hold Shift, tap the right arrow 3 times. So now this is the bottom row of my fill area. So I'm going to press and hold Control and Shift, and I'm going to tap the up arrow. Okay. So now what I've done is I've selected this whole region from row 2, which is ready to be propagated down, all the way down to 360. So again, right, what do? Want to fill it down, Control D. We type Control D. That actually fills the entire table for us. Let's see if we hit the down arrow. We might get lucky and go to, oh yeah, so if you hit the down arrow, that goes to the end. And so here you can see that this is the amount that you owe. They peel off the interest and pocket it. And then this is the excess amount, and lo and behold, the excess amount exactly pays off the amount that you borrowed. And so from this point on, your outstanding principal is 0. Okay? So there is a weekend Excel homework that's based on this amortization table. It'll be up on McGraw-Hill assignments within the next half hour to an hour. Okay? So practice. My advice, you know, you do whatever you want, is to practice using these shortcut cells, because when you hit 314 business finance, you wanna, it'll help you to be efficient. So you know, you notice that I used some of the really common ones I use, and then for the more complicated ones, just use the mouse, right? But what you want to avoid is using the mouse every single time, because when you take your hands off the keyboard, move the mouse, you got to reset your hands back, and it kind of slows you down a little bit. So it's worth it to learn the keyboard shortcuts. Okay, so have a great weekend, and we'll be back here as usual Monday.